Okay, we finished the gameplay recording. That took forever. I thought I was gonna be in and out in like 5 minutes even. Took me 18 minutes to complete the level. I kept on falling, and I don't know, those elliptical platforms, they especially the last one, they were just doing my head in. Anyways, I hope you'll enjoy the game. I'll insert a link to the package or something. I'll also it'll mainly be for Windows. I'll try to package it for Mac. Unfortunately, I do not have a Mac, so there's no way I'll be able to test the quality of the build. So fingers crossed. Here's a quick run through of the level. So we imported the Asian Village asset pack, which comes with all the background, the architecture, you name it. And then in C++, what we did, we created an actor class for inheriting from actor, an item pickup class. And then we created moving platform. This was in the last video. We've got an interface, so created an C++ interface to allow us to communicate with pickup objects. This creates scalability. And then that was inherited by the item pickup C++ class. Within our blueprints, so we've got obstacle course. I then created, so you're already familiar with the elliptical path platforms and you name it. We created a BP item pickup attack. I'm just gonna give a quick overview. If people are interested in detailed tutorials on this, I can cover them. The idea is very basic. So we've got our mesh, and then we've got our effect, our Niagara particle effect for when we destroy the item or we pick up an item. And through our interface, which we've inherited, we can see from here, class settings, attackable, interface attackable. So whenever there's a call made, a message is sent out. So any actor or blueprint that has this interface will receive that message, right? They're subscribed to this phone line, and then the message will pretty much say, hey, disable the collision, right? I noticed there was a weird bug because we want to destroy the object last. So we disable collision, then we hide the object so the object is still there, and then we activate the effect. And only after we fire the effect and the pickup sound, right, that's when we destroy the object. There's a little check at the end, an if or a branch node as it's called in Unreal Engine, where we check our very last actor, which is the toad, right, at the very top in the Portaloo, and that has an actor tag, the actor tag being end game. So we check for this tag. If this actor has end game, right, we're gonna get our class BP dragon, and we're gonna say, hey, raise the dragon, Shaolin monk, arise. And afterwards we can destroy this this item pickup. So yeah, it's pretty straightforward, very simple logic. The tricky, challenging part was within our character, you see. So I'm gonna open up Kwang player character, where you can see the additions I made. For some reason, the physics asset wasn't interacting or triggering any overlap events, which was very weird. So what I ended up having to do is to add a collision box on and attach that to weapon socket. attach that to the socket, do the right dimensions and everything, and then I set this to be world dynamic, and we wanted it to overlap destructible. So our pickup items, I set them as object type destructible. That's another key point there. So our pickup object here, you see collision is enabled, query in physics, it's object type destructible, and we pretty much ignore everything else, but we block world dynamic and destructible. Could have just done overlap. I was trying to introduce some physics, wasn't working. Anyways, the key thing is those need to match up. So this overlaps destructible objects, and then within our logic, the idea is when our weapon box overlaps a certain actor, if that actor implements an interface, in this case attackable or can be picked up, you name it, with a condition that we are in an attack state, so we are left clicking our mouse button, we then fire the message hit by a weapon. So all the actors are just told, the player has hit something, the player has hit something with a weapon. And because we know this item is attackable, so we're like, yeah, this item is attackable, the player did something good, let's increase their score, right? Which we're tracking as an integer. And then we call out a dispatcher, hey, score was updated. So whoever is listening, in this particular case, this would be our widget blueprint. I'll just pop into our widget blueprint. So go into widgets, widget blueprint, score HUD. So we've got a very simple widget, canvas, horizontal box. We have our score icon, which is a mining toad, and then we have score text. And you just gotta be careful with the sizings of the fonts and stuff so they match up. And just a quick note on the horizontal box, I set the size to size to content, and then I fixed the size of the toad, so 72 by 72, and then I did the text. Oh, we don't want to swap those around. Okay, and the key thing is the score here, it needs to be a variable so we can edit it. What then happens in the background is when we begin the game, right, this widget blueprint is constructed, or when it's constructed, here's what happens. It checks for, we get the player character, we cast to check is the Quang player character, we set that reference, and then this is for other logic I was planning to implement, but the key thing, we bind to the dispatcher from Quang. So on score updated, we bind to that. So whenever that dispatch is, think of it like a megaphone. Whenever someone speaks into that megaphone, this widget is listening. So, score has been updated. What's the new score? Let's set our text to the new score. And going back to our Quang character, we also then, I want to make it dynamic and random. So we have an array of sound cues, right? And we have our mouth, shall I say? So we have an actor attached to our mouth, sound actor or component, shall I say? And we just change the sound to a different one, and then we play. So yeah, it's like little emos every time we pick up something. Key thing to note on begin play, we get our score widget and we add it to our viewport. These are all just inputs, very basic stuff. Okay, and that's most of the logic, to be honest. I think I shared Dragon. So, okay, no, I haven't shared Dragon yet. So the way the Dragon works, I was like, there needs to be some sort of indication the player has completed the game, some sort of reward. So the way I set it up is, we have our dragon in the level, right? You can see it's raised to the ground. And when the game starts, we want to hide it from the player. So we just set the location of the mesh, not the actual blueprint itself, just of the mesh on the Z axis. We just hide it under the side, right? And then we also save our player reference. When we hit that last toad, right, which has the tag end game, we raise the dragon. We play our add thrombo audio cue, so ground shake, but we also have a world camera shake, right? And the world camera shake gives us that earthquake effect. So this is inherits from camera shake base. It's a blueprint actor. I've gone with a wave oscillator, and these are my variables. So I pretty much turned everything else off except Z and our pitch. Yeah, and these are the variables. You can find various YouTube videos online. Anyway, so we've got this effect. We play this toward camera, and the source or the epicenter, we want it to be our play character. You could set it to the dragon, either try different, and the outer radius is, it only affects the cameras within this range. And we also have a timeline being used to update the location. So fire timeline, this timeline is, it's got a curve and it's a duration of 4 seconds. So over 4 seconds we raise the dragon, and when that is finished, that's when we fade out, you know, the rumble sound. The camera shake itself, it's set to be 5 seconds. Okay, I believe that comprehensively covers how I've set this up. I'll just do backtrack. So our bullet train portal here, you can see moving distance, so 8,000. It's covering a distance of 8,000. I've given it a bit of an angle, both the mesh. So I've angled the mesh -75, and then you can see we've got the velocity because we want it to go in the x direction as well as the y and z direction. I haven't applied any rotation. As we go back, these are just rotating platforms. As you can tell, rotation rate of 30 degrees, and right, our good friends here. So we have 3 elliptical platforms, right? And what I have done is, so the center is pretty much their current location, and the length of A to B, so this is the diameter, shall we say. I've made it a circle essentially, 1200 by 1200. So this, think of this as 3 circles overlapping each other. I forget if the mathematical term is concentric. I'll have to look that up. Anyways, and then we've got delta time, which is 0.4. So that's the time we update, you know, the calculation, or shall I say the angle, the rate at which we update the angle. So the angle intervals for calculating where our platform should be on that circular path. You could probably use a spline, it would be much simpler and more visual. Here I was trying, you know, get into the nooks and crannies of C++. It will be interesting to see how those two would confirm performance-wise. Then as we go back, we've got another rotating platform, except here we want the player to go on top. I'll just increase this to like 20 degrees, so it doesn't get dizzying and stuff. Over this side, so I just kind of juxtapose this platform. So one is going horizontally, the y-axis, and the other is going up and down, so z-axis. I added some barrels along the way, which the player can hit as they simulate physics. They're physics actors, but also, if you remember, our weapon collision box blocks physics actors, so that makes it a bit more fun and interactive. Got a simple asset here, which you can use as a tightrope. I added a money toad in the middle, so you know, somebody might get distracted trying to swing at the totem misstep. And then back here, this one is actually an elliptical platform, as you can see. So in the x-axis, that's 500 units length, but in the y-axis, that's 1,000. So you've got a proper ellipse. Overall, yeah, I was hoping this would have stayed on so they could like block the player's path, but they just fall off at the start of the game. Overall, yeah, I think it turned out pretty well. Happy with the course so far. It's there's lots of opportunities for me to branch out and extrapolate, you know, and generate ideas, express creativity, you name it. This was just from the first section, right? I could have gone full on with just that lesson with the platform, create multiple levels, you know, or gone out to the forest, because in the tutorial, right, it's all about going across the river. So you go across the river and there's like supposed to be a forest and stuff all the way over here, which, yeah, that's weird. Yeah, so they in the tutorial there's supposed to be a forest here, but it's not in the game. Anyways, so there you have it. That's the platformer. Let me know if you have any questions. I'll try to. I don't have a lot of time right now, but I'll try to help out where I can with the answers. And yeah, that's a wrap.